Welcome to the viewers. Now we discuss the subgraphs. So at first we consider G be a graph and H is said to be subgraph of G if the all vertices of H and all edges of H are in G. So what happens there? Now if we consider a graph like this, if G be the graph and consisting of the order triplet like vertices B dash, edges E dash and incidence function omega dash, this is I think this is the considerations. And now if we consider the following diagram here, if V1 dash with the vertices, V2 dash, V3 dash, V4 dash, if an incident functions here E1 dash, if we consider here E2 dash, if here E3 dash, if this E4 dash, if another vertex like V5 dash, if we considering this like E5 dash, another vertices like V6 dash, like V6 dash, and here is a loop for the edges, it is E6 dash and the loop for E7 dash. So if we considering this type of graph, if we considering here as G and then another set like it E7 dash and here is a V6 dash and V5 dash, if we considering it as H1 and another is like this V1 dash, V2 dash, V4 dash, if we considering these like E1 dash, here it is E3 dash, and if we considering here like this E2 dash, if this is considered as H2, V4 dash, V5 dash, and if its edges is E5 dash, if it's considered as H3, then if we observe all three graphs, in all three graphs the all vertices and edges are included in G, that's all are in G. So what is our observations? We shall denote these graphs if we know that all edges and vertices are included or are in G, then we said to be all the graphs like H1, H2, H3 are subgraphs of G. All H1, H2, H3 are subgraphs of G, as in all the cases its all vertices and edges are in G. And now we shall denote if the vertex of the graph be VG and edge of the graph VEH and vertex of the subgraph is VH and edge of the subgraph is VE, then we can say VH is the improper subset of VG and EH is the improper subset of EG. But here we given the sign improper subset, not proper, because considering the trivial cases, because this G is the subgraph of G, so it is a trivial cases, that's why we consider in this way. Otherwise it is proper subset, it is a proper way. Now we considering spanning subgraph. Let G be a graph and H be a subgraph of G, then H is called spanning subgraph of G if VH is equal to VG, and if we observe that if the subgraph H span the graph G, then if the subgraph H spans the graph G, then EH must be improper subset of EG. So from this two we can give some of the ideas about the spanning subgraph. What spanning subgraph is, we already understand. Now if we consider diagrammatically to clear the idea of spanning subgraph. Let us consider the given figure. If it is V1 dash, V2 dash, V3 dash, V4 dash and V5 dash. If we considering this type of graph, now joining this, we considering here like V3 dash, okay, then it is V4, if we joining these two vertices, this and as well as joining these vertices in this way. If we considering it as a G with a graph. Now here in the spanning one like this, v1 dash, v2 dash, v3 dash, v4 dash and v5 dash. If we considering as h1 suppose and another graphs v1 dash, v2 dash, v3 dash, v4 dash and v5 dash. If we considering it as h2, then if we look at the figure, h1, h2 are the subgraphs of G. Because why? Because all the vertices of h1 and h2 is the vertices of G. We observe here v1, v2, v3, v4, v5. So we declare it as a spanning subgraph of G. The graph h1 and h2 are subgraphs of G from the given figure. V of h1 is equal to V of h2. It is clear, all vertices have same. V dash 1, V dash 2, V dash 3, V dash 4, V dash 5. Both h1 and h2. And also it is the same cases of G. So it is V dash of G. So we can declare it as a spanning subgraphs. Hence, both h1 and h2 are spanning subgraphs of G. So finally, we understand what the spanning subgraph is. Now we consider here like the deletion of vertex and edges. What happens there? We observe. If G be the graphs and V dash be the vertex of G, then G minus V dash is the subgraph of G. We obtain by deleting the vertex V dash and also deleting the edges incident on V dash of G. So G minus V dash is a subgraph induced by the vertices Vg minus V dash. The maximal subgraph that doesn't contain V dash. If we clear the idea about the deletion of vertex and edges with the help of the diagram. Now, so here we consider deletion of a vertex from a graph. We clear this idea with the help of a diagram. If we considering here v1 dash, v2 dash, v3 dash, v4 dash, v5 dash, and if we consider here a loop and if we consider here, that is a e1 dash, e2 dash edges, e3 dash, e4 dash, e5 dash, e6 dash, and e7 dash. And now if we look from the given figure, v1 dash, v4 dash, v2 dash, v3 dash, it is e4 dash, e1 dash, e2 dash, and e4 dash. So what happens there? So it is graph G, and it is graph G minus deletion. Which deletion is v5 dash? It is clear. If we delete these vertices, all edges automatically will delete it, and these two. So we are getting finally this figure. This is a concept of deletion of a vertex from a graph, and here it is a subgraph. G minus v dash is obtained. It is a subgraph. So we find a subgraph G minus v5 dash, which is obtained by deleting v5 dash from G. It is G and G minus v5 dash. So in this way, if we delete another vertices like this, we are getting different type of figure. So many figure we have. If we deleting these two v1 dash, then we can get this two type of figure. And if we consider here from deleting this v1 dash, we are getting this type v2 dash, v4 dash, v3 dash, v5 dash, e2 dash, e3 dash, e6 dash, e5 dash, and it is also e7 dash. Here is the graph, that is G minus v1 dash. It is also subgraph, if we consider. This is subtractions. v1 dash subtracted, so all other remain same. So it is a subgraph also. So we can also say G minus v1 dash is a subgraph of G. So here we find also the idea how to delete a vertex, and there is also possibilities of deleting edges. How to delete the edges? If we considering a graph, that is a deletion of edges. If we considering the graph v1 dash, v2 dash, v3 dash, v4 dash, v5 dash, and if we taking the edges e1 dash, e2 dash, e3 dash, e4 dash, in this way. e5 dash, e6 dash, and if we delete any edges like e6 dash and e5 dash, finally we obtain v1 dash, v2 dash, v3 dash, v5 dash. Here is a correction. If we consider here, it is a v4 dash. v4 dash, and now the edges, if we without deletion, e1 dash, here it is e2 dash, here it is e4 dash, it is e3 dash, and if we delete two edges of e5 dash and e6 dash, we are getting this result. And if we considering only one edge deletions, if it in this way e5 dash, then the result will be, if it g, we are getting g minus e6 dash. This is a concept, g minus e6 dash. So we understand how to delete the vertex and edges from a graph, and actually we give some glimpses of idea about subgraphs and deletion of edges and vertex and spanning subgraph also, with the help of some pictorial representations. If you like these videos, like it, share it, subscribe the channel. Thanks for watching.